So I've been asked in a couple of previous videos to provide a little better view and conversation about how I've been replacing ICs. This is the Amiga 500 motherboard that we rescued in some earlier videos. It's up and working. I just tested it again. There was a couple issues with this motherboard. Actually, there were several. We looked at in other videos. There was a lifted trace over here in the power section around the video generation. There was a missing pin off of the Fat Angus, and I ordered replacement. We've had an issue with Paula here, not making good solid contact in the socket. The device has had the pins kind of bent in a weird way, and I kind of bent the pins again, and I think I have good connection. I resoldered all the connections on several chips under the board, thinking that might have helped it. It was stuck in the yellow screen, which is an indication of memory issues. I finally replaced the 4 ICs down here, which is why they're in sockets, and that seemed to have solved the issue. Whether one of these ICs was bad, or it was a bad solder joint, even though I had resoldered these, I don't know. I'm going to work under the assumption one of these was bad. I then demonstrated with these 2 chips here my process for, again, replacing chips. But I was asked to get some more close-up video, and that's what I'm attempting to do here. I'm not super thrilled with the focus. I've got a lot of zoom going on 2 cameras here. My hands are going to get in the way in some of this video, and I'm not quite sure how I'm going to work around that. So I'm going to go ahead and replace this 74LS32 here. I have no reason to suspect it's bad, but I have plenty of LS32s in my stock. I can afford to replace him. So the process I'm going to use is, first off, I want to protect the printed circuit board. You can replace ICs. The DRAMs here, the common TTL stuff, the 555, that stuff can be replaced pretty easily. They're really common parts. It's a little more difficult with the Commodore specific chips in the Amiga. Those are pre-socketed at the factory, luckily. The DRAMs can even be replaced. The idea here is to protect the circuit board. If I have to destroy a device to get it off the board, I would rather sacrifice the device than take a chance on trying to keep the device and lifting foil on the board and just creating a large mess. In that previous video, when we looked up here at this cap, there had been foil lifted, and let me find the pointer if I can find it, and maybe we can actually get this in frame here. The foil, there's a resistor up under here. The foil over to pin 2 on this hybrid device here had been lifted. Somebody did that by, I think, heating the capacitor that used to stand here and rocking it back and forth and prying it up out, and they lifted the foil off. And so for this repair, what I did was I took and laid the replacement capacitor on its side. I bent the lead down so it would make contact to the resistor lead here where that piece of foil went, and then I kind of bend it so it came around to pin 2, and it's tack soldered in those 2 locations, and I just took the negative lead and bent it to go down into the negative where the original cap was. I'm going to replace this with the proper capacitor. This is 2200 microfarads. It really should be 33, and once I get to 3300 in, I will hot snot this configuration to make a little bit more solid connection. I believe these 2, get back in frame here, I believe these 2 capacitors are really just bulk decoupling for the video section to remove as much video noise as possible. So with all of that said, I'm going to tackle getting the 74LS32 out of here and replacing him. And I'm going to sacrifice the device to do this. I'm going to use a pair of flush cutters here. Pretty common. These are still fairly new and sharp. And what I'm going to do is get down on each device pin up at the shoulder where it enters the package. I'm trying to do this left-handed and I'm right-handed. Do my best here to get this all in focus. And I'm going to get in here and I'm going to do that, and I've just clipped that lead loose right up at the shoulder of the package. I'm doing this because I'm sacrificing the device. Use a Instead of 74 LS32, he can be replaced easily. Jelly bean part. It's kind of hard getting into these. A pair of flush cutters with a little finer tip would work. I could probably grind the edges off this slightly. But I've clipped the leads down the one side, and let me see if I can get in here and clip the others and get this really captured in video. And again, I'm working at odd angles for myself here, which makes this a little more clumsy. And there's the last leg. I've got one pin still attached right there. Here it is. So we've cut him out here. You can see that I've trimmed the leads. I'm having trouble with focus. As close to the actual package as possible. He is now scrap. Let me get focus back down in here. Actually, I'll pick the board up and try to get it in frame here. So you can see I've got leads that are standing up through the board. So the legs are still there through the board, and the idea now is I'm going to pull those leads up out of the board one at a time. The idea here again is to protect the copper on the board. I've got the soldering pencil heated up over here. I've got cables all over the place because of the camera is in the way. There's a bunch of ways to do this. And I'm going to heat from the top side of the board. And what I'll see is right there. So in this case, the pin, get this on camera if I can find it. I got lucky on this one. Can I get that to focus? Not really. The pin stuck to the end of the soldering pencil there and just lifted up out on its own, which was beautiful. I'd prefer that. Sometimes I can get in here with a little flat screwdriver and use the soldering pencil tip and the screwdriver. Again, pin lifted out. There's a little pair of tweezers, and I'm just going to pluck each pin up out. This one's requiring a lot of heat, so I'm going to back off on the heat right there. And I'm going to add a bit of solder to the tip. And what that solder will do is, that fresh solder, I can see that's on a ground plane, will make it easier to conduct the heat. He is loose. And there he is. So everything I'm doing here is in an attempt to protect the circuit board. I really can't emphasize that enough. Around DRAMs and things where there's, this is another one with high thermal mass, add a bit of solder to the tip. He's kind of moving, there he is. You can see when there's high thermal mass, it takes a bit to get the lead to pull out. So we've successfully pulled out the leads from one side of the board. Again, because I'm working on camera here, it's making this kind of difficult. Let me look up at the other camera and make sure we're somewhat in frame. I'm working right there. And I'm just going to take the same process. Let me get a block up under the board so it's not rocking on me. That one's lifted out. That one's lifted out. Dwell time here is important. The more time you spend with the heat. Oh, this one's being tricky. All right, got him. On the board, the more potential issues are with the trace and causing the trace to lift. And that one's got a large ground or power. Actually, that is ground there on that side. That is pin 7. So this may take a bit of heat. And of course, the screwdriver that I'm using to make a pair of tweezers with here steals heat away as well. See if I can get this back in frame and get some focus on it. There it is. And you can see that I've successfully plucked all the pins out. The holes are of course still full of solder. It's this set of pads back here. So the next thing I'm going to do here is clear those holes out. A little more difficult to hold the board solid here. They are right here. I bet I'm not centered up well on the other camera. Take a peek at the other camera. I think we're okay. You're probably going to be working with a tool, one of these. Clean it out well each time you use it, so it's not, when you release the little clip, it causes a lot of vibration and you'll get a solder dust that'll pour out and kind of make a mess on the board. Before I try to solder back out these holes, I'm going to add fresh solder to every connection. Believe me, fresh solder makes this easier to do. Solder's cheap. It's your friend, both in putting parts in and getting parts out. If you have a hole that's really stubborn and doesn't want to clear, add a little solder and try again. So let's see if my little El Cheapo solder back here will do the job. So I'm going to heat that up. And yeah, first look, that looks really good. That one looks really good. This one is on a power or ground plane. It didn't clear just because of the large thermal mass. I'll come back to it. This one's got a super fine trace attached to it. It cleared out well. This is again on a power. It didn't clear out. The tool here is jamming up, so I'm going to dump the solder out that's in it. Not sure why it's suddenly unhappy. It's not pulling back really well. Oh shoot. The inside of the tip here is all plugged up. It's got a bunch of solder in it. So I'm just going to use a little screwdriver and just kind of gently clear that out as best I can. If I can get it to clear. Sorry I'm doing this off camera. I'm just digging down inside of the tip, trying to remove the solder that's stuck inside of the little nylon piece. That sounds better. We'll continue on. on to the next pad here. This has again got a lot of copper behind it. It didn't clear. And the tool's jammed again. Oh, this is frustrating having the tool keep jamming up. Let's see if I can. It's just packed with solder inside. There it is. There's what was caught inside of the tip. I don't know if you can see it. It's just a big mess of solder that was caught inside of the nylon tip. Much better. Back to the soldering pencil. We'll try that again. And I'm being delicate here. I'm not scrubbing the pad with the tip of the soldering pencil. I'm making contact about a quarter of the way in on the pad. Rather than covering the pad with the tip, I'm heating the pad from the side. That way there's room for the vacuum the tool is pulling to lift the solder up out. I know my arm keeps getting in the way. So, if I can find it here on camera and get some focus, you can see that all but 3 of the traces have cleared, and all 3 traces are attached to large copper pores. So in this case, I'm going to try to vacuum those from this side of the board. And of course, the first thing I'm going to do is add fresh solder on this side. This guy. I want to make sure the board has open underneath where the holes are so it can draw air up through. If I'm sitting on a flat surface, it can make it harder to draw the air up through. Let's see if I can get this here. I'm going to spend a bit of time on this guy and see if I can get him to, yeah, that drew clear just fine. I'm going to do the same thing here and just give it a bit of dwell time to flow through, and that worked fine. And that one didn't. Well, 2 of the 3 are cleared. There's the most copper on this side of the board for the one that's giving me trouble. So I'll come back and heat from this side again. If you've seen me use the Heiko desoldering tool, you can see that it works really well for this. It's got a very large thermal mass. And it works well for this. Still didn't get it. Oh, there's always got to be one that's going to be stubborn. Well, I'm going to try it one more time. And I'm going to leave even longer dwell time here. Wow, he is really being stubborn. That's because I've got a large amount of solder on this side. Again, I'm starting to worry about lifting traces here. I've been on this for quite a while. We will heat from this side without adding solder since there's so much loose solder there. Man, he's just really determined not to clear out. Now I've got a larger version of the tool here, which is actually in much better shape. This little one's pretty worn out. I will try one more time with the large tool. Still not. No. Well, this is rather ugly. I don't think there's anything in there. Well, and again, I can see the solder ball has fallen through and not got pulled off. So I'm just going to come back to this side of the board. This one's a real struggle. Clean the tip so I don't have dead flux on it. Man, oh man. What? I'm starting to wonder if there's something down in the via. No, it's really not going to clear. So at this point, something I will try is, let me find a resistor here. And I'm just going to heat it up and poke a resistor lead down through the hole, just in case there's something physically blocking in there. I've already spent way too much dwell time on this. Luckily, it is a heavy copper pour. Trim the excess lead length off from this side, just in case there was something that picked up. I'm going to push through. This has got to be the most stubborn clean out I've done in a long time. And we'll try one more time. Not even close. What is up with this? There it is, finally. So I can't tell you, honestly, if there was something in the hole. I have got a little bit of solder splash here, which sometimes will just wipe away, as that did. I can't honestly tell you if there was something down in the hole that was just getting toggled back and forth, but that's clear enough now to get a socket lead through. Let me find a 14-pin socket. Do I have any in this box? Yeah, I've got a few. Well, maybe not. Let me run over and grab another box of sockets. Come out of there. There's a 14 pin. Pay attention to the notch in the silk screen and the notch on the socket. Where'd the roll of blue painter's tape go? My normal method, little blue painter's tape, doesn't leave residue behind. is hard working around the camera. Excuse me. Oops. Gonna clean the tip well. I'm gonna pick 2 pins that are not power and ground on 2 corners so that there's not a lot of thermal mass. I'm gonna put my finger on the socket and reflow that and just gently push up to make sure the socket is in flush, which it is. And now I will walk through this and resolder it. And this is the hole we had all the issues desoldering, and it's just got such a huge thermal mass. It's got a large copper pore on both sides. Hopefully the majority of this is being caught on camera. I'm going to reflow the one where I tacked it in originally and then heated and pushed up, just to make sure it's not cold. There's a large thermal mass there. I'm not particularly happy with this solder joint. I think it needs a bit more solder. And this one again's got, actually no, it's one of the ones I tacked originally. And we have the socket successfully in place. Of course, that flux should be cleaned off. So we've got our socket in there. I have someplace I pulled out a little bin of chips. And there's a 74 LS32, which we will insert. Now, I don't honestly know. There's the audio filter down here. Whether this LS32 is involved in audio, or it's next to the reset circuit, or I don't really know what it's used for. I didn't look that close at the schematic. Let's get video plugged in. Actually, let me zoom out here. Got video plugged in. Sorry for bumping the camera. See if I can zoom out here as well, and hopefully center the camera a bit better. Oh, I keep bumping the camera. Apply power. The little converter box is on. It's being powered from an external DC source. The monitor is on. And let me turn the Rigol power supply back on. And I'm right back to a white screen, so I haven't potentially broken anything. So hopefully that gave you some hints. I'm looking at the Amiga Workbench version 1.3 boot screen. I'm surprised I got this far without a floppy attached. So we are functional at this point. Although, you know, whatever this controls, maybe I've, you know, accidentally damaged, I don't know. Where this is going to be a lot trickier, and I'm debating whether to do a video or not, is removing one of the DRAMs and keeping the chip intact. Because when the chips were put through the board, the leads were bent over the board. They weren't just flayed out, they were bent over onto the board. It's really rather difficult to get the devices out of here. You've got to straighten the pin back up straight. It's still got tetch into the side of the socket. It's really hard to get the solder to release. You know, I fought that with a couple of devices here before I just clipped the leads out, because they, you know, can be easily sacrificed. But I think for this demonstration, that's everything I wanted to talk to, and we'll talk soon.